If you still didn't grab a beer, do yourself a favor. Otherwise, you will detect my bullshit, and everything is broken then. Okay, I'm going to talk about Kotlin DSL. It was advertised as in 1 hour. I will make it under an hour, I hope. Now, why am I talking about this topic at all? I'm not a language designer. I'm not a language developer. I'm not a compiler designer. I have no credibility, so everything I say is not true. But DSLs and languages are kind of close to my heart, even though I'm not really a developer. Is it my mobile or what?
That's me.
Oh, it was a nice sound effect. So if you want to follow me and follow my bullshits on Twitter, here I am. And the kind of DSL I'm going to talk about today is embedded DSL. So if you have heard about DSLs, like the main specific languages at all, they kind of separate into 2 main groups: external DSLs and internal DSLs, which are embedded DSLs. And external ones are the ones you develop the parser, compiler, whatever, transpiler for, and they feel like a complete language but tailored for specific needs, right? And embedded DSLs is something where you use your existing language, and then in certain parts of your application you start writing DSL-like structures for the specific tasks. So we are going to talk about this second group of DSLs here. And here's an example. That's a library, a Kotlin library for generating HTML, right? So in here you see something like a structure, but there is not so many strings that you have to write when you write HTML. What's that? Do you like it? Do you use it, by the way? No? Because you don't write HTML?
I think,
nobody writes HTML.
I think normal HTML is better, but it's funny how they use the plus sign, hacked the plus sign for that.
Yes, so there isn't like a weird example of the plus sign. Maybe it's not the best example, by the way, because if you write HTML in strings, in IDEA you can use language injection, and it's probably even easier to write HTML using emmet mode, where you write an expression and it expands into like a document. You write one line and it expands into one document. But here's like this is just an example of how like a DSL-like structure and the syntax sugar gets into normal program, because in the beginning you can see like create HTML, normal function, and then something weird is going on. And by the way, I can even show you that. I have a little project right here. So how it looks: create HTML, head, title, and maybe that weird sign as well. We can take a look what it is actually. My title. If we go into the plus sign, we can see that it's actually a operator. So it's overloaded operator right there. Anyways, sorry for this. Why would you use this kind of approach to generate structures at all? Feels like an overkill. So it's, first of all, it's a declarative approach, right? So the most ideal way to use DSL languages is to when you can approach this task at hand in a fully declarative manner. However, in this case, there is a question. If you use this kind of approach, for instance, for configuration, not for generating the structures, then the question is, why would you use like a programming language instead of just using some sort of a standard properties format like YAML or JSON or something like this? Here's an example. I can show you why you could use this. Say we want to generate something in a loop. So you don't have a loop in JSON, right? In here you can, like, to do something like this. Item in items. I don't have items yet, but then you could do whatever, item value, whatever, right? So this is kind of a nice way to approach this structure generation inside your application, and that's just one single task that is scoped with one problem that you are working on. It doesn't mean you have to write a whole application of in this kind of dialect, right? Okay, I have slightly more complicated example next. So I will start with a couple of examples, then we go through some of the language features that enable this approach, and then I have like a little bit more sophisticated example. Okay, another example of using Kotlin DSL is in TeamCity, which is the continuous integration server I'm working with. It looks like a spaceship. But the point here is that there is a way to configure jobs inside the server by using Kotlin DSL. So let me show you an example of that. Application. So what I want to do here is to build a project using two steps. First, to build it, and second, to test the artifact I have created. This is the configuration file that is used by TeamCity to configure those steps. And to actually implement that, I have to like give it a configuration. So I have a project, and under the project I may have like different steps. And one of the step abstractions is this build configuration type, which is, you can call it build type, you can call it build configuration. I have used Jenkins, for instance. It's a job or an item. It's the same. And then I give it an ID, say build my app, and then give it a name, which will be just a label, build my app. And then I may want to point at some source repository, which could be the same as this, like where the settings are, right? So I don't want to specify like a specific GitHub repository. I will just say that, okay, build from the same repository where you find the settings. So root, and for that, we actually have a little DSL context that provides it. Settings root. And next, I know that this project that I'm building is a Gradle project. So I want to build Gradle here. Steps, and I have a Gradle step there. Tasks equals clean build, right? And then I want to expose an artifact as well. Artifact rules. I know that it builds into library directory, and it's called app.jar, whatever the result is from the Gradle task. As you can see, I'm specifying it before the actual step. I could specify it later as well, so it's kind of a declarative approach to the configuration here. And what else could I do here? Oh, I probably can now just specify the second build, where I'm going to test whatever I have just created. Build type, ID, test my app, name it just for the label, And then I should specify a dependency on the previous type, dependency, dependencies, dependency on the build type. So what should I write here actually is either a type of this build type, because I can extract it into a class because it's a programming language, or I can extract it into variable all at once and give it like a name, build1. Then I specify the variable right here, and I say that, hey, it should be an artifact dependency, and I should take artifact rules. No, just all the jars that I get from the previous one, and so on. So and I could have like a step for testing as well. Whatever I want to do, like maybe a script body, script content actually. Echo, no, du minus k to all the jars. So if I commit it to the repository, then the continuous integration server will pick up this configuration, reconfigure itself, and get me a nice looking UI with the diagram that kind of visualizes how my application is going to be built. Let me show you that as well.
Can you show the imports as well here?
Just a sec. So this is how it will look like. Remember, we had two configurations. The first one, the second one, we have an artifact, and so on. So we asked about the configuration, or imports, right? Here they are. So the trick here is that it's a work in progress, and I hope that we can get rid of those imports for good. So there will be no imports.
Yeah, I mean, but if you want to write it in your IDE instead of the notepad, then you need to download a bunch of jars, probably.
That will be a task of the plugin. That is coming in. It's not yet implemented in Kotlin support, in the IDE tooling itself. Once it's going to be implemented, we can take advantage of that and be able to provide kind of through the plugin. We could provide those libraries without imports.
But if you're writing your own DSL, then imports is probably a must. So
yes.
So basically,
it's a matter of tooling. If you provide your own DSL and you don't have IDE support with this feature, then of course you will have to add imports. That's true. Okay, but that's a more sophisticated example. I will get back to this one to show you the shortcomings of DSL approach later. But here I just wanted to demonstrate that this is like a real life thing. We use Kotlin DSL in many projects ourselves to build IDEA, to build TeamCity itself, to build all the products. Okay. So let's get back to the slides. I still have 2 more slides to go. Okay, we have a demo. So what I'm going to talk today are some of the features in Kotlin that enable this approach. There are a lot of different things in Kotlin itself, right? We are not going to take a look at all of them. We are going to take just some of them. I highlighted just random ones. Don't read it, right? It's not a promise that I will talk about the things. Okay, at the end of the talk, if you remember nothing, whatever I say is bullshit, right? Nobody cares. But one thing you should remember is this, those 10 characters. Lambda with receiver. And I will explain what it is, and actually it's the main trick to use when you're building your DSLs in Kotlin. Okay, so let's get back to the IDE, and we probably don't need anything else after that. Okay. Remove this guy, remove this everything. Okay. Can you see it in the back though? Yeah. Should I make? Okay, good. Very good. All right. Oleg told me that Anton was speaking about Kotlin here, but nobody remembers anyway. So we probably should go over some small things that probably are essential to understanding what I'm going to talk about further. So I'm not going to talk about all the language features. I'm going to talk about only the basics that we need for this talk, right? For this topic. First of all, functions, right? We have this main function here, print line hello planet West, right? So this is like essentially the most advanced program we need. Anyways, what do we need to declare functions? The fun keyword, first of all. It's strange how it's sorted. Fun2, fun0, fun1, some random order. Okay, let's declare a function with 2 parameters. Give it a name. What kind of name we give it? I don't know, beer. And give it a type, something like number. No. Okay, whatever.
You're still stuck in Java.
Yeah. Wait. And then we maybe have like, okay, maybe add a second parameter later. So we have like a basic structure of this function like this, how we declare it, right? We could remove this one because it's not needed. We can specify the return type right here the way we want it, if we want to do that. If we have one-line function, for instance, we can just say that, okay, this is what we want. We don't need like those curly braces and anything, and we don't need the type here as well because Kotlin compiler can infer it for us. So functions work kind of like this, right? We can use functions as parameters as well. So for instance, in here, I could use something like this. So here I specify a functional type. So we have one parameter, the first one, and the second parameter is a functional type, which could be a function that takes no parameters and returns nothing. Right? So this is just a signature of a type. All we need. Next, if we call this function, say like this, and provide nothing as input. What?
This is not Java.
Wait. Okay. Yes. Sure.
Just curly braces.
Yeah. So if we have it like this, we can actually then move. And an ID, by the way, tells me that if I could. Yeah, you could probably see the gray underscore. No? A little bit. Those who are in the front row probably can see it. It tells me that, hey, you can actually move the Lambda argument out of the braces, so we can see it like this, right? Which already kind of creates a DSL-like syntax here, syntax sugar, for us, so we can actually take advantage of it already. Then there are some nice features with the arguments. For instance, if we had like a default value specified for the first parameter, we can probably even skip this one, right? And skip the braces and have this nice structure already, just clean one without any arguments. Or say that number should be 10. We have name arguments here as well, which sometimes is a nice thing if you have too many parameters and you don't remember in which order they have to be, and you don't want to enable those hints in the ID. like this. Then, name parameters is a nice thing as well. Lambdas. A little bit about lambdas. So, because they are kind of essential for us to build a DSL here. Let's create a lambda, which is essentially a function. It could have parameters, it could have a return type. Vol lambda, something like this, and say that, okay, again, what did I do wrong? Yeah, unit. So this is a declaration, right, of some value. We say that it's a lambda, and we get to do something, like print something out. Print hello lambda. Good, right? So this is how we declare lambdas. However, okay, let's keep this lambda here for a little bit. So we know about functions, we know about functional types, we know how to pass the parameters as functions, or functions as parameters, we know about lambdas. Now the next thing is learning about extension functions. So say we have a string, something like hello, right? And we want to show it. And there is no such string in string class, right? Because, well, nobody created it for us. We can actually add it there. String show, and then println this. So essentially what is happening here is that we are creating a utility method with this syntactical sugar. Like normally in your Java code you would have some kind of util class with static methods. Well, compiler is doing it for us, but it's just a nice way to express it. That we say, okay, please all string class objects should have this show function, and then please do this thing for us. And this will be referring to the instance of the call site, right? Is it something new for you? Like everybody's so silent. You should grab more beers.
Like in my favorite C#.
C#, yes. Every Java programmer wants to program in C#.
Scala.
No.
In Scala, other extension functions?
No, there are traits. No extension functions. Okay. So we know about extension functions now. We know about lambdas. How about extension lambdas? They call it lambdas with the receiver, which is just a fancy way to say that lambda with a scope. What if we wanted to use this lambda as an extension for something? Why not? Lambda. Boom. So we have it. So this is like a trick that is used in the DSLs, and this is what you probably have to remember from this talk. Everything else, I should say, is bullshit. This one is important. It's possible to use this lambda and narrow the scope on a specific type, right? And we'll see how it's used in the DSLs when we start creating those. There are some other nice features that are not related to the talk today, but probably I should mention them anyway. It's only one that is left because I have talked about name parameters. Inthings functions. So for instance, we are building a test framework, and we want some assertions in it to be expressible in a nice DSL-like way. Should equal hello. Why wouldn't we create something that would look like this, right? Should we don't have this method, we can implement it. So we can create an expression extension function for the string, and it will be an infix function. Yeah, so you see it already compiles, right? And could be something like this, equals return equals s. No? What's wrong? Oh, because it should be Boolean.
You don't need the return.
You just write equals this.
Whatever. No, we need a return.
But you can use the short
Yes.
declaration.
Yes. It's not the point. The point is here, right? The point is that we have infix function that will act right here. So it's just an example. It's not important for the next example anyway, but I just wanted to say that it exists. Alrighty, so you kind of have now an understanding of Kotlin, you know everything. We can move on. So in the example I want to demonstrate you, the main point is that it's not building the language itself, but using it with a library that already exists. So in your projects, you already have some Java classes that you probably either cannot or just don't want to change, or because you cannot change probably because they are in the library, right? An external library or something like that, and you want just a nicer way to express the task for this library. I'm going to use an example which is prepared by my colleague, so credit goes to him actually. And the example is like in here, like see in the structure, we have a corp model package, and there we have some Java classes. We call them Java something on purpose, so that they would identify as Java classes, right? And there we have a nice looking code in Java. If we take a look into those builders, we have like nice looking builder that, you know, sets some properties and then calls a build method to create some instance of an object, like classical builders. Twitter builder, client builder, so they look nice. Everybody would understand that. And this Java code here that we have, well, it's reasonably verbose and everybody could read it and understand. But we could play with it and see what we can do with this new approach of DSL-like structures for this code. Let me copy this one and put it into the main thing. So it converts into Kotlin for me, and it doesn't look much better. It removed some of the type declarations because it uses val, but soon we will have var in, or do we have already? We already have var in Java. It removed new keyword from here because in Kotlin there is no new keyword, and it kind of changed a little bit this println statement because previously we had system out println. Now if we run it, compiles, runs, but there is no toString method. First of all, you probably want something that looks a little bit nicer. And let's start refining it. So we start with a small problem here, and then we will see what else can we do. Obviously, imagine, like, as I said, we cannot change the original files. This is the point here. We are not changing it. We are only writing code in this file, and we are not writing code in Java right now. So what could we do to fix this? We could implement an extension function for this type, which is a Java type. It's not a Kotlin file, right? We go there, and say we start with not with the extension function, but with just normal one, the Java approach to this problem. We could do something like this. Print client, right? No, to console client. Why not? And let's create a function, string. We should change this template, it's too big. Hope it's visible right there. So what could we do? Like return client Twitter handle, and maybe add some other string as well. Client company name, maybe like this. So there are some nice little steps that we can do here. First of all, convert into template, because we don't like string concatenation at all. Secondly, probably we don't want those curly braces and use this short notation. No? Oh, like this. And then we don't want this type here as well. So it looks already nicer a little bit. And if we run this program again, it displays what we expected, right? So it displays a username and Twitter handle and company name. Okay, but that's kind of a silly Java approach here. What we could do better is maybe do it like this. To console string, maybe. Why not? It's still a string concatenation right here, but we can move it inside the string again after we finish. So what we need here is a new function on that type, right? So Java client. So we are adding new extension function. And I don't want to type it. Create extension function right here. Going to return string and use this guy the same way. So we add it's just this. So it will look the same way, but we just have a nicer way to express it. And then obviously we could move into string again. So we don't have string concatenation.
If you name your new function like toString,
that's a question to you. What do you expect to see?
Unfortunately, it will not work, but
okay.
It would be really nice.
So overriding with extension functions doesn't work because they are not virtual. But this one is a little bit ugly because of those braces as well. What if we just remove this and make it more concise? We can do the same for the properties that we do for functions. So we can have extension properties instead of extension functions. Vol Java client console string. Do I remember the syntax correctly?
Yes. You can even keep it on the same line.
And do it like this, right? So that should work. Run again. So we added a property, extension property, instead of the function. So this one is not used. This is what we are using now. Okay, but that's kind of a silly small problem. We started with that. We want to do something about this guy, about this whole structure, and somehow simplify it. And what we can do with all those features that I just demonstrated 5 minutes ago. We can start with just a small step here by adding a function that takes in a consumer. It's a Java consumer. This one, right? Came in Java 8. Oops. And takes in a builder and builds it. Boom. Just a simple function, returns the Java client. What we can do here now is to type something like val client equals create client consumer, and move in this block right here. And builder. Okay. Oh, we need to specify a type as well. Java client builder. No. Builder. Yes. Oh, and then we can remove a couple of lines already.
We're going to make it even better with the built-in apply function.
Okay, so here already IDE will tell us that, hey, you can do better. This Java client builder is not needed, right? So we can remove it. Actually, the next step would be to get rid of this consumer. What if we use Java client builder like this? We don't need the accept anymore because it's functional type, and the only thing we need is to call it. It's a function. Now we call it inside our create client, and then it does something. It does something that is actually written in here, and we return the result. So in here we can get rid of the consumer, I guess, already, because we are not passing it in anymore. The client doesn't. The create client method takes only the functional type, which is a lambda, right? With a parameter, and well, it returns nothing. But here, IntelliJ already tells me that, hey, you see the underlines, right? Hey, you can do something about it. And what does it tell me? Move lambda argument out of the parentheses. So we don't need parentheses anymore, because remember, we can pass a lambda out of this braces list, right? Out of the parameter list. Okay, the next thing is, if I have one parameter only as an input for the functional type, I can actually rename it to it. And it is an implicit one, implicit argument, so we can actually get rid of it. Becomes nicer, right? So we had something like this before. Where is it? And now it's slightly better. This one. Now, one thing that bugs me about this one, about this code, is the repetition of it in front of those statements in here. So why do I have to write those over and over again? Now, if I turn on the hints for the lambdas in IntelliJ, it will tell me that I'm using Java Client Builder context. And I want to get rid of this guy. So that first name would be called on an it implicitly, right? So I wouldn't have to specify this it argument in there. What I can do is to create an extension for this type, because then extension would work in the scope of that type. And remember about extension functions and extension lambdas. So I can move out the type out of the argument list. And now this lambda that I'm writing here will be running inside that context that I'm just that I specified as a receiver. So if I go here, I can see that this one is not, is compiling now, and I can safely remove this guy from here. Oh, nice. It's already like I have just create client, first name, last name, and I have just two those blocks that I could do probably the same trick with. Why not? So let's, if I could remember this, I could just type it, but I don't want to. I will copy those from my backup. So let me remove this annotation, I will add it later. So I add a couple of extension functions to the existing builders, to those two guys, to the Twitter builder and to company builder. And what I can do now is to use that extension function, because it was in the client builder, right? So we are in the scope of client builder. Now we can use this function inside this scope, actually everywhere, but I mean, in this scope we have the scope of Java client builder. That is why we can call it. And the handle, so we don't need to call this client, like this instance, something, because inside this Twitter block, the scope will be different. The scope will be of Twitter builder now, and Anton Arhipov, and we can remove these two lines now. And
can you write first name equals inside of Twitter?
First name equals, yes, by default I can, but I probably know the trick to make the compilation fail. Okay, we'll try next. We'll try next, and we will try exactly that, right? And same for the company. Oh, I removed too much. Probably don't need this one. Create a block and move those guys in here and like this. All right, so looks much nicer, right? So the point I want to make here is that, first of all, we have an existing code. It can be your own code, it can be a library code. This code could be fulfilling a specific task, and maybe this task could be implemented using some syntactical sugar on top of those DSL-like features that exist in Kotlin to get this kind of structure instead of, let's compare, split horizontally, no, vertically. And the example here. So this instead of, well, it doesn't fit in, but anyways, instead of this, right? So that's the point I wanted to make. About your question, let's try it. So there's like a nice trick. I'm not sure if it will work, but maybe it will. Let's call it annotation marker, DSL mark. No, let's call it like this. DSL marker. So this annotation actually allows you to control the scope. And which example you wanted? This Twitter, right? So if we use this guy, mark it with the annotation. By the way, this annotation is also used to do highlighting in DSL structures. That's why you see this Windows marker in here. So you can override it, and you can see that it's highlighted a little bit differently. And also it would work with auto-completion a little better, because it tries to put those DSL marked methods on the top of the auto-completion list.
So you mean that DSL marker will disable outer scope visibility?
We'll check. I'm not sure. It works in some cases. I've tried. It really fails the compilation, but I haven't tried with this one. First name. Nope. Not in here. But some other places it actually fails. Okay.
So the trick is that DSL marker, is it a built-in annotation?
DSL marker is Kotlin annotation, yes. It's in package Kotlin. There are some weird things going on around tooling to support this annotation. I'm currently on EAP. Sometimes it works, like now, for instance. I mean, the highlighting and auto-completion, but sometimes it does some weird things in some beta versions, because it's not, I think it's not in the final. I mean, the annotation is in the final version of Kotlin itself and the standard library, but not in the final version of the plugin for the IDE. Okay, so it was a nice example. It probably, I hope it's a practical one, but there is one limitation, like general limitation. So I'm now philosophizing a little bit. So let's get back to this TeamCity DSL. So in TeamCity, we specify the build types like this, and sometimes we specify them as proper types. Let me demonstrate you that. So I could. So if you, for instance, if you don't write it by hand, but you go to TeamCity interface and you want to download the configuration in Kotlin format, it will actually generate one for you, and it will not look like this one. It will look a little bit differently. It will declare all those build types as objects. For instance, build my app. And as you see here, it only created a name property for me, but not ID. The ID is derived automatically from the type. So the type name will be the ID name. And in TeamCity, this ID is kind of essential, so it's required. If you don't specify it here, when you specify it as a Lambda, it will actually fail on the server. So the DSLs are, like in Kotlin, are statically typed, right? So that's the main kind of feature of the DSL. But the compiler would not check if you have specified the property or not, if the property is null or not. Only your application knows if this property would be required.
Why not make a required parameter of build type?
Right. So to fix this problem, you would do something like this, right? ID build my app. But now it's a trade-off. The trade-off in a way that when you design a DSL, when you design it to be a declarative one, and you want consistency, like one thing to strive for is consistency. And the most consistent DSL would look like almost like a JSON with no normal braces, but just with curly braces and assignments. That would be like the ideal one. And here you're kind of sacrificing it because the only way to actually specify that is to use like a parameter, which is required one. and you still cannot be sure if no one writes null. Oh, okay, there's nullable, of course, but you know. So that's just a general thought. Like if you are designing the DSL for,
I think required parameters in DSL is a good thing, much better than like not having them.
that's true. But here we have already some legacy code. We cannot. Well, we would add that, but we already have this function in there. That's kind of one practical example from real life, right? So there is a requirement for an ID. It's much nicer to write this specifications like this than like this. And ID is required one, and we can check it. Another cool thing about all this approach is that, okay, in TeamCity we have plugins. A lot of functionality is actually implemented in plugins, and plugins may have their own DSL, right? Their own specific snippets, how they configure themselves. And since Kotlin is like extensible, those types, those core types, are extensible through extension functions. So every plugin could actually contribute its extension function to the core type, like to this project here, and say, or maybe let's say we have like a triggers in here. Triggers. And say some plugin wants to add a trigger that pulls a database, DB trigger. So it would contribute an extension function for this triggers type, and we would have the new DSL snippet in our configuration. So it's easy to extend. Right, I think we have a few minutes, but you can ask questions now. I think I've covered everything I wanted. So if you didn't remember anything, like if you were sleeping all the time, just make a picture of this one, right?
But still, in most cases, you can just use the apply function, and you don't need to write your own stuff.
Yes. Well, yeah, I didn't mention apply function. It's good you mentioned. Let's get back to the example. I actually have it in my example here. So here's an apply function. Why am I using it here? Because I cannot change the Java company builder, and there is no constructor that would take anything else, right? So there's just a default constructor, and I cannot use it like this. S would not compile. Instead, I could use apply function and be happy with it.
You can even use it in your code instead of this company thing.
Instead of the company, what?
Yeah, you can write just instead of the company in your own code, you write like company builder apply, and you get almost the same thing.
Yep. Well, no.
A company builder in front of apply.
Yeah, it's a client builder, but it doesn't look as DSL-ish now.
Yes, but
It would look like a generic DSL, a very generic one. Okay.
So the pizza will arrive in 12 minutes, so please keep talking.
What is the state of DSL for Gradle? Because you are using Gradle here, but not the Kotlin version.
Okay, I didn't show you the very good question. Where is it? Is it? No, it's not the one.
This is Groovy.
Groovy. Here I have. So yeah, you can use Kotlin to in Gradle scripts. I was actually curious if anyone at JetBrains uses Kotlin in Gradle, and I was surprised that yes, there's a lot of projects that they use, like build Gradle KTS, and most of them actually, almost I couldn't even find that many projects that use Groovy in Gradle. The state of it, it was just announced yesterday that RC1 RC1 is available. for this one. So I don't know when it will be 1.0 final, because it's not actually JetBrains who's developing it. It's someone in Gradle Inc. is developing it, but I know that our guys are helping, but it's not in our hands. More questions? Did you like the beer? No, there's one hand. So only one person dropped the beer. Two. Okay. What?
There will be more beer.
More beer and pizza.
Actually, why would you need to have this HTML ugly DSL if in Scala you can just write plain XML instead of...
Isn't it removed already? In the late, in two... Oleg.
Is it?
Oleg.
I'm sorry.
XML support in Scala, is it removed already? I think it was.
It should be definitely, yes, removed.
Maybe it's still there, but it should be removed.
No, I've heard stories it was deprecated, and I think it was removed either in the latest version or in 3.0.
So
Don't use XML at all.
But why is it worse than writing HTML?
No, it was just an example. I don't think it's worse. Like, I would personally write HTML in string if I had to.
Like React does it, why Scala should deprecate it?
No. I would do it something like this. Say that it's HTML.
Of course,
I'll say HTML.
you lose type safety, of course.
Whatever. IntelliJ does it for me quite well, but I don't know. And expand it like this, and then I could have like a separate screen, a split screen for those snippets to edit with all the auto completion and stuff.
Will the compiler optimize this create HTML call into the string?
This one?
Yes.
No, I don't think so. I think there is quite a lot of things to go through when, because it's dynamic as well. You can have loops in there, and
Yeah, but if there are no loops, can you fold it into string?
no, I don't think it optimizes anything there. All right. Okay, let's grab more beers. I don't
I have
know.
a troll question.
Yes,
What do
go for it.
Kotlin developers think about Scala?
They don't think about Scala. They have Kotlin.
It's like first they do Kotlin as the gateway drug to Scala, or the other way around.
No, I don't think it is.
For me, it was the other way.
Well, there are some other ways to create DSLs, internal DSLs, right? In some other languages, like the easiest example is the fluent APIs in Java, when you have those chain calls, like method, braces, dot method, and so on. So a good example would be Apache Camel, for instance, where you specify the data flow from file, transform, put into database, and so on. The other way to implement DSLs would be using those different JVM languages, and one of those could be Groovy, right, which takes advantage of its dynamics and actually works in runtime. This DSL feature works in runtime because you would have like a hook into the invocation of a method that doesn't exist, and then you can, by some logic, create something like by the name of the method and so on. So it's easy to create this kind of builder. All the builders in Groovy are implemented using it, like method missing hook at runtime. And then you have two options, Scala or Kotlin, which kind of are comparable, I think, in regards the features that you can use for creating the DSLs.
But
Yeah, so in Scala, the
would you
extension-
implement the same thing using implicits, or?
Yes.
In most
the
cases, you would
pattern-
use implicits and sacrifice compilation time.
The pattern for creating extension methods is called modestly pimp my class.
And it uses implicits.
Yes.
So basically, it's in runtime, it wraps your object into another class.
No, it's all compile time. Implicits are compile time.
Yep.
Okay.
In here, you don't have implicits because they don't exist in the language. All right? We are losing people now. Hey, grab the beers, guys, and let's stop it.